This is question 8 from the first CSAT sample paper. So we're given a 4x4 grid of points, so 16 points, and we're asked how many triangles can we make out of these points, so with a vertex that its vertices is 3 of these points on the grid, like this or like this. So how many triangles can you make? If you want to have a go at this question yourself, pause the video now. Okay, so there's 2 ways to approach this. One is to pick a point and think about how many other points there are we can make triangles from. And the other way is to think about all the sets of 3 points and then see how many are triangles. In either case, what can go wrong? Why can't we just pick any 3 points? Well, the reason is those 3 points might lie in a straight line, so it might just be these 3, for instance. And that's not a triangle because they're on a straight line together. So we need 3 points that aren't on a straight line. So let's do this the second way and think about picking 3 points. What are all the ways they could make a straight line? And then the number of triangles will just be the number of sets of 3 points minus the number of ways they can make a straight line. Okay, so the most obvious way we can make points a straight line is if they lie on one of these rows. So if I pick any 3 points from this row, that's not going to be a triangle. So how many ways are there of doing that? Well, in each row there's 4 ways. So we can think of that as 4 choose 3, or we can think if I'm choosing 3 points from this row, that just means I'm choosing to exclude 1 point, and there's 4 points I can exclude. And then there's 4 of those rows. So the number of ways we can make a straight line out of 3 points is 4 for each row, and then multiplied by 4 rows is 16. And then the other obvious way is to do a column instead, so that's going to be exactly the same. There's 4 columns. We can choose 4 sets of 3 points in a straight line from each column. So that gives us another 16 straight lines from here. But there's also diagonals to worry about, because if we get 3 points on a diagonal together, then those will still be on a straight line. So how many diagonals can we make? Well, you can see we've got these short diagonals here. So we can have a diagonal like this, and we've got this diagonal and also this one, and then we can also use the reflected versions of those, so that way and that way. So there's 4 of those short diagonals, and each of those has exactly 3 points. So the only way we can choose 3 points on that diagonal is just to choose exactly these 3 points. There's only one way per diagonal. So that means we've got 4 diagonals and 1 set of 3 points per diagonal, so that's 4 straight lines we've got there. 4 sets of 3 points in a straight line. And the other diagonal to worry about is these long diagonals. So we've got 2 of these, 1 in each direction, and each one is 4 points, so there's 4 ways of choosing 3 points in this diagonal, just like in these 2 cases. So that means we've got 2 lots of 4 is 8 for those 2. Are there any other diagonals to worry about? No. So for instance, these ones are too short, those only have 2 points. And then if you choose something at a different angle, that's not going to fit in the grid. So if we had a larger grid, it might be a problem. But if we say try to join these 2 points with a diagonal, the line between them is going to miss all the other points. And likewise for these 2, likewise for this one and this one. So all the other diagonals we can try to make, they only have 2 points in the grid. So they aren't a problem. So these are all the straight lines we can make. We've got 16, 16, 4 and 8. So now what we'll do is work out how many sets of 3 points there are, and then just take away these cases we've already found. Okay, so how many sets of 3 points are there? Well, we're just choosing 3 things from 16, so we're doing 16 choose 3. And if you remember, that's 16 factorial over 3 factorial times 13 factorial. But it's easier to remember that we just take 16 factorial, so 16 times all the numbers less than that, but we cut it off before 13 because the 13 factorial on the bottom will cancel with all those terms on the top. So it's just the terms, if we're looking at 16 choose 3, it's just the first 3 terms, 16 times 15 times 14. And then we still got the 3 factorial on the bottom, so that's 2 times 3. And to work this out, we can do a bit of cancelling, like we can cancel the 2 into here and the 3 into the 15. So that just becomes 5 and 7. So we've got 16 times 5 times 7, and the bottom's disappeared. And now this is easy to work out because 16 times 5 is 80, and then we multiply by 7, and 8 times 7 is 56. So we just get 560. And now we want to take away all these things. So we're doing 560 minus 16, minus 16, minus 4, minus 8. And altogether the thing we're taking away comes to, let's see, 32, 36, 44. So doing 560 minus 44, and that comes out to 516. So our final answer is 516.